walk through the instructions and let you know what kind of issues are arising because of certain things that we do and certain things that have been changed with the platform. So it's going to be intense, long session. So let's get started. I hope everybody can hear me. And please mute yourself so that we don't have any interruptions. Okay. Did you start recording, Elena?
We should be recording right now, yes.
Okay. Okay, so I'm going to quickly go through the internals of Apache Spark and give you a quick introduction to Spark ML. Okay, this is going to help you really, truly understand what you are doing in the assignment. Okay. And then we will have plenty of time for a Q&A and Elena to walk through the instructions. So yeah, this is, we're going to basically cover distributed computing. And Apache Spark is a compute engine for clusters. And we will look at certain data structures that are available in Spark, the Spark framework, called RDDs and data frames. RDD is a resilient distributed database, and an evolution of RDDs is data frames. After that, I will give you a quick introduction to machine learning with Spark, and we will look in some detail the concept of transformers, estimators, and pipelines. And if there is time, I will discuss one example, which is gradient descent. Otherwise, we will just continue with code walkthrough. Okay. Now, if you have any questions, you can post them to me or to the whole class. I'm listening on the chat. Okay. So now, if you have studied last week's materials, watched the lecture, you should be very familiar with Mapreduce. Okay, this was the first and a sort of primitive computational technique or strategy that was used on HDFS. Okay, there are clearly two parts to this computational paradigm. One is map, and the other is reduce. And you should be familiar with this slide. I explained all the operations in some detail last week. So I'm going to very quickly refresh these concepts so that you can understand the difference between Mapreduce and Spark. Okay, Spark was actually a generalization of Mapreduce, and so it's quite useful to start with Mapreduce. Okay, so on the left, I have shown 4 compute nodes. Okay, as examples, there are 4 compute nodes, and the file that is that has the data, structured or unstructured, is distributed across the cluster, and it is stored in HDFS. So what happens during a Mapreduce operation? Okay, let's say you're doing a word count, or something similar, or a k-means clustering. Then the function that you write in the mapper class is going to be shipped to all the nodes that have the required data. Okay, so you know that the file, if it is a large file of textual information, it is chunked up into blocks of 256 MB, replicated 3 times, and stored across the cluster. Okay, and so you have to find at least one version, at least one replica for each block, and ship the mapper function to that particular node. Okay, and the mapper is used to locally compute results on that data. Okay, so you don't move the data to the computation, you move the computation to the data. Okay, so let's say you are doing either a word count or k-means algorithm, k-means clustering. Then the function is going to take key value pairs, and it is going to emit intermediate key value pairs. And I have shown some of the, I have shown examples on the right-hand side. Okay, so each table you see here is has a lot of key value pairs, and this is the result that comes out of the computation. Initially, these results will be stored in memory, and as the memory buffer starts filling up, it will be spilled into the disk. But how it is spilled into the disk depends on what kind of classes you have written to follow the mapper class. So, for example, you can write a partitioner and a combiner, and what they will do together is further chunk up the results into smaller files. Okay, so the partitioner will take all the results computed by the mapper, and it will apply a hash function to each of the key values. Okay, so what does the hash function do? It just translates the key value into a number, and then that number is divided by the number of reducers. Okay, let's say we have 500 reducers. What will be the output of this operation? Okay, let's say you take the key value, pass it through the hash function, and then you divide it by 500. Okay, the result will be a remainder from 0 to 499. Okay, so there will be 500 distinct remainder values. Okay, so I've assumed that we have two reducers in this example, so I am dividing the output of the hash function by 2, and I'm calling them 1 and 2. Okay, so when a row has a remainder of 2, okay, which is shown here in red, that means the data in that row needs to eventually go to reducer number 2. Okay, so now the partitioner computes these remainder values, and then it segregates the rows into two smaller files. Okay, the first file has all the key values that will result in a remainder of 2. The second file has all the key values that will result in a remainder of 1. So the first file then has to go to reducer number 2, and the second file has to go to reducer number 1. Okay. Now, within each one of the subfiles, you will often have the same key value repeating several times. If you use a combiner, okay, that key value will be grouped together, and you can see that in this example. Okay, so you have two K4s, they are combined together, and you have the values added up here. Okay, that's the function of the combiner. So this is what spills the data into the disk. Okay, there is not enough space in the buffer to hold all these results. So these files are stored on the disk. Okay, so imagine if you have 1,000 mappers and 500 reducers, you are going to have 500,000 small files that have to be stored in the disk, and then they have to be shuffled over the network to reach the corresponding reducers. So that takes a lot of time. Okay. Now you will see that Spark does a lot of innovations to reduce this time. Okay, the time taken to chunk up the results into a large number of smaller files and the time it takes to shuffle this data across the network to the reducers. Spark is going to try to reduce both these times, okay, both these latencies. And once it is the data is shipped to the reducers, you have the reduce operations. Okay, now if you have to repeat this process iteratively, for example, if you are doing k-means clustering, okay, you have initially set 10 centroids, okay, each mapper is going to act on each point and it's going to emit a key value pair. The key will be the point and the value will be the distance from each centroid, okay. So you have done one iteration and then you can recalculate the centroids and you go through the second iteration. And remember that you're going to have tens of millions of points, okay, and tens of millions of records, okay, and you have to repeat these iterations till the centroids don't move much, okay. You know this from your previous courses. Okay, so how do you use Mapreduce to accomplish this? Once the first set of distances from the centroids are calculated, you have to store all the data again in HDFS. That's going to take time, right? You have to store new files into HDFS. And then you restart the Mapreduce again for the second iteration. And you know that typically, k-means algorithm can take anywhere from 100 to 1,000 iterations. So remember, just think about all the overhead involved in iteratively computing the centroids. Okay, so this is exactly why Mapreduce was not very efficient. Okay, so we come now to Spark. You may already know that the initial work on Spark was done at UC Berkeley, and this is the title of the paper published by the creators of Spark, Resilient Distributed Data Sets, a Fault-Tolerant Abstraction for In-Memory Clustering. Okay, that was the title of their paper. And you see the first author, Matai Zaharia, was the primary person involved in developing Spark, and you know that the company now that is mostly involved in advancing Spark and cluster computing is Databricks, and Zaharia is the CTO of Databricks. Okay, so he's continuing this work in Databricks. So that's a little bit of history. You can actually Zaharia has written a lot of books on Spark. You can read them online, and you can also watch a lot of lectures by Zaharia on on Spark, as well as the roadmap for the future roadmap for Spark development. Okay, so what is the main distinguishing feature of Spark? As I said, Spark is the compute engine for clusters, get data stored on clusters. So here you see 4 nodes. These are the 4 columns. Okay, and let's assume that you have 4 different data sets stored across the 4 nodes. Okay, the first data set has 3 partitions. Okay, partition 1 is in node 1, partition 2 is in node 2, and partition 3 is on node 4. Okay, now if you are running a Mapreduce test, okay, you don't control these partitions in real time. Okay, you say what Mapreduce does is it ships out the map function. It goes locally to each one of those nodes and all the computations take place there, and the results are returned to some other node, okay, which is running the reducer function, okay. During this process, you have no control over these partitions or these data, okay. What the main feature of Spark is that it gives you an abstraction called an RDD, okay, a resilient distributed data set. Okay, what it is a wrapper, kind of a wrapper around these partitions, okay. So you no longer need to think of these things as, individual blocks or replicas distributed across the node, but this is a data structure, okay. It's a data structure just like an array or a list, okay, or a vector, or a cell. It is a data structure. An RDD is a data structure, okay. So there is this singular abstraction that Spark gives you, okay, which holds all the data you are trying to manipulate and compute, okay. So you have now four different RDDs. Those are, again, four different data stores, okay. So that is the main, that's one main feature of Spark, okay. Now, so here you see how computation happens in Spark. You got the executor JVM, so this shows you the memory. All these different partitions are stored in memory, and this is an RDD, okay, and these are the CPUs. The map task transforms them into, again, results that are stored in memory, and then, okay, here you see sort and spill, okay. Now this is just one example of how this thing is executed. This is what happens in Spark 1.4, okay. Now we have moved away from it, but I want to tell you how this improves over Mapreduce, okay. So remember, in Mapreduce, you had partition functions, okay, and they were generating lots of smaller files. Here, that does not happen, okay. Instead, what happens is the data from each mapper is sorted and spilled into the disk, but it is not chunked up into smaller files. Instead, you have a single file, okay, one single file, output file from each mapper, and then you ship it across the network, and you merge the files in an intelligent way, okay, so that you don't need to separate out the files or the rows by their key values. Okay, so I'm giving you an example here. Let's say you're doing word count, and the first set of results look like this. Okay, the letter A appeared 936 times, AB appears 6 times, and so on. Okay, what this is a binary heap. Okay, it is a binary heap, and it can be ordered by either the key values or the values. Okay, either the keys or the values. So here I have shown a binary heap ordered by the keys, okay, and that is each output file. And you can do some highly optimized merging, okay, at this level, okay, so that you combine the key values and you do the reduce operations in a shorter period of time, okay. This is an example of what Spark does. Okay, if you ask people generally, how is Spark better than Mapreduce, they will say it's in-memory computation, it has RDDs, and things like that. That is true, but behind the scenes, Spark optimizes almost every operation. Okay, every sort operation, every it optimizes the spills, the merges, okay, it does a lot of that, and that's how it saves time. It saves computation time. Okay, so this is very important and an often overlooked feature of Spark. Okay, Spark is not just a simple generalization of Mapreduce. What these guys do often is, they do a lot of research, they do lots of simulations to figure out what techniques save time, reduce computations, and things like that, and then they implement those techniques into the framework. Okay, so these are the main features of Spark. Apache Spark, as I said, it is a generalization of Mapreduce, especially suited for iterative computations. And these are the 6 things you need to remember about Spark. Okay, it has specialized data structures, 3 of them, RDDs, data frames, and data sets. We'll look into them in detail. There is, of course, in-memory computation, and Apache Spark uses DAGs, or directed acyclic graphs, that optimize computations. Okay, and there are 2 types of computations allowed in Spark. One is called transformations. These are also called lazy evaluations because the transformations are not executed as soon as you apply them. They are only executed when an action is triggered. Okay, actions are actually the functions that produce outputs. So when you trigger an action, then Spark analyzes all the DAGs associated with the transformations, comes up with an optimal computational strategy, and then starts computing. Okay, and the 4th point is what I explained just now. It optimizes all sorts of sorts, merges, and shuffles. You can see, Databricks and UC Berkeley have published a lot of papers on, how they were carried out these simulations. And then Spark also provides a very rich set of APIs in Scala, Java, Python, and R. You will be mostly using Python, I guess. But, you can also easily switch to Scala if you want. And it has a number of APIs for machine learning, SQL, streaming, and graph. Okay, so those are the 6 things that you really need to know about Spark. Okay, so I mentioned transformations and actions. Transformations are the, are also called lazy evaluations, and actions are the ones that actually trigger computations. Okay, so now let's look at transformations in some detail. Okay, so there are 2 types of transformations. 3. One is narrow dependency transformation, and the 3rd is shuffle. Okay, so you can see the examples of narrow dependency on the left side. Okay, each small square is one partition, and each rectangle is an RDD. Okay, so here you have 2 RDDs. Each RDD has 3 partitions. Now, if a operation or a task, okay, happens in such a way that there is at most one partition of the child for each parent partition, then that is a narrow dependency transformation. Okay, so you can see this is partition 1, 2, 3, partition 1, 2, 3. Okay, this partition, okay, uses the first partition from this RDD and the first partition from this RDD. Okay, so these 2 are coexisting partitions. They are probably on the same node. Okay. So when you do a join like this, you have two RDDs and you're joining them together. Okay, but the join is a special type of join where each partition comes from only the co-partitions. Okay, so then that is a narrow dependency. Okay, that's called a narrow dependency. Here, each partition transforms into itself. Okay, so this is when you do operations like map and filter. Okay, what happens is the data in each partition, okay, is transformed and stored in a partition on the same node. So there is nothing that is being shuffled across the network. Okay, so this is another. These two functions are also examples of narrow dependency transformations. Okay, here you are doing union. Again, this can be a narrow dependency because all you are doing is gathering all the data in these two RDDs and you're putting them together in a single RDD. Okay, so join with co-partitioned inputs, map, filter, union are all examples of narrow dependencies. Okay, when you do group by key, then that's going to be a wide dependency operation. Okay, why? Because the same key could be in the first, second, and the third partitions. Okay, let's say key number 1 could be here, here, as well as here. So all of those rows, records have to be shipped to the first partition. Okay, if you're going to group by key. So that's why it is a wide dependency operation. Similarly, if you do a outer join or a left outer join, for example, between two sets of data, let's say these are customer records and these are orders. Okay, if you're doing an outer join to see all customer and orders, all customers and orders together, then that's going to be a wide operation because you got to ship. You have to join the customer list here with customers here, with orders here as well as orders here. Okay, so it's going to be a wide operation. Okay, so that's those are the two main things you need to know about transformations. And here I have listed. Okay, let me just give you this list first. Okay, usually these transformations have narrow dependencies. So these are maps, flat map, filter, and so on. These transformations have wide dependencies, and you can see here left outer join, right outer join, that kind of stuff. Okay, so let me stop here and see if there are any questions. Does anybody have any questions? I'm going to take after Rena's example and start asking questions if there are no questions. Do we have any questions so far on RDDs? Is anything not clear or do you understand how you can use, how transformations and actions are used in Spark programming? Okay, so let's continue. I'm going to give you a simple example and illustrate, both wide and narrow transformations. Okay, so let's assume that a big store like Amazon wants to know how many shippings were done for payment during a certain period of time. Okay, it just wants to know total number of shipments. Okay, so there are two categories of members. There are prime members. If it was a free shipment, okay, so we're gonna call that 0, the value 0. If it was a paid shipment, then we need to count that shipment. Okay, so paid shipments have a value of 1 and free shipments have a value of 0. Okay, and for other members, non-prime members, every shipment is paid, so all the shipments will have to have a value of 1. And then we just add up all the values across all the members and all the orders, okay, to get the total number of shipments. Okay, so now let's look at RDDA up here, and these are non-prime members. Okay, so you got customer 1 with a bunch of orders, and those are stored in partition 1. Customer 1 also has other orders that are stored in partition 3, and so on. Okay, so these partitions contain all the shipment data for all customers who are not prime members. Okay, so the first thing you will need to do then is a group by operation, because you want to calculate the total number of shipments for each customer. Okay, so when you do that, obviously customer 1 data, okay, will have to flow here, and it also has to come from the third partition and flow into this partition. Only then you can sum up the total number of shipments for customer 1. Okay, and now in RDDB, you have all the total shipment numbers ordered by the customer value, which is the key. Okay, so remember that once you do a group by operation, all the results are going to be already ordered by the key value, the key. Okay, which in this case is the customer ID. Okay, now let's go to C. C are all the members, okay, all prime members, some of whom had free shipments. Okay, so what you need to do with C is take the RDDC and you apply this map function. You're going to map each customer to a tuple, okay, with the customer ID and 0. And the resultant RDD is D. E is all prime members who paid for the shipment. Okay, so here you just emit the same values. Okay, they already have a shipment value of 1. Okay, and then you need to do a join to get the total shipments for all the prime members. Okay, and when you do that join, you're going to do a union, and that is going to be again a narrow operation, because all you have to do is throw those values together and then count them. Okay, now finally, when you want to reduce, when you're ready to do the reduce operation, you will have to club together all the shipment values for each customer. Okay, so what you do is a join of these two RDD. Okay, and so look at this. Why is this part a narrow transformation, but this part is wide? Just think about that for a minute. Okay, why is this transformation a narrow dependency, while this one is has wide dependency? Any suggestion? You can type. Yeah, Tom says they have to have one-to-one correspondence. That's right, because when you do group by, okay, you have already ordered the customers by the records by the customer ID. Okay, so you don't need to do any more shuffling. You've already ordered them and grouped. That means added up the values. But here, this is an union, so all the results are jumbled up here. Okay, there could be records for customer 1 here in the first partition, and then there could be some in the third partition, fourth partition, and so on. So these need to be, again, sorted. Okay, so this is a wide dependency operation. So the main point here is the one type of operation like join can either have narrow dependency or wide dependency, and you have to pay a lot of attention to this when you are developing your Spark program, because wide dependencies are going to take a lot of time. Okay, there's going to be latency associated with shuffling all this data around. Okay, but narrow dependency transformations will be faster. So wherever you can help, okay, you try to use narrow dependency operations. Okay, so that's all I have to say about transformations. Now we will go to the the next part of RDD, which is resilience. Okay, as I said, RDD stands for Resilient Distributed Data Set. So what does resilience mean? It means that while you are doing your calculations, if a particular node or a rack or a switch dies, then you only recompute what was lost. Okay, you don't have to recompute all the results. So this is very well illustrated here in this figure. Let's say, yeah, this is the same Amazon operation. Okay, you've done a group by, map, and then a union, and then let's say you are about to do a reduce operation. Okay, you are trying to join these two RDDs, and when you're about to join the two RDDs, this partition is lost. Okay, so one main feature of RDDs is that they have metadata. They have metadata, and the directed acyclic graph, DAG, is part of the metadata of each RDD. Okay, so from the metadata of this RDD, the DAG operation that resulted in this partition, okay, in this data. So all you have to do is execute just that DAG, and you will. So that means you go back here, you find that you from the metadata of this RDD, you find out that the DAG for that RDD, which takes you back here, and then you compute this, restore this, and then you carry out the reduce operation. So just because you lost this partition doesn't mean you have to recompute this whole RDD. All right. So that's what is referred to as resilience. Okay. So now let me show you a simple code and related to the internal operations we have been discussing. Okay, let's say we are just doing a simple word count. Okay, you should be familiar with this code by now if you have been looking through the assignment. So this is average length is equal to the Spark context dot text file. You give this file name, and then you are applying a flat map. This is the function. Okay, this is the flat map function. All it does is it takes each line and splits it into words. Okay, and then to the result of the map, flat map operation, you are applying a map function. Okay, which is this lambda. It takes each word and makes and emits key value pairs. The key is the word itself. The value is the length of the word. Okay, so and then you're doing a group by key. But let's stop right here. Okay, so you have created an RDD by taking a text file. Okay, reading in a text file, and then you are applying this flat map function to each row of the RDD. So what this flat map does is it splits up each line into words, and then you are applying the map function, which takes each word and generates key value pairs. Okay, so that is stage one. When you're writing a code like this, this is what you visualize. Okay, you have an RDD, flat map. You don't have to go across partitions. You just take each row, and you can think of split as putting commas between the words in a line, right? It just generates a flat map, and it sticks that the entire line in here. Only now there are commas between the words. Okay, what does the next operation do? It takes each word and calculates its length, and now it does a map. So let's say there are 10 words in the first line. So now you're going to have 10 rows, okay, one row for each word, and you will have key value pairs, which will be the word and the length of the word, okay. So now it should be very clear that this does not require any shuffling, okay. So all of this are narrow dependency operations. The data flow from here to here, okay. Similarly, data flow from here to here. And then finally we are doing group by key. So now you have a word like, I showed you an example, Abbott. It is here, it is also here. So you need to bring those two records to the same partition in order to count or in order to add up their values, okay? So group by key results in wide dependency transformation, all right? And then in stage 2, once you have that, you're applying this lambda function which calculates the average length, okay? And average, okay, so that is stored in this RDD. Now, as I said, these are all transformations, okay? Flat map, map, group by key, map are all transformations. So when you write this piece of code, you assign the result to RDD called average length, and you hit a return, okay? Spark does nothing. It generates the directed acyclic graph, okay, and it has a logical plan for executing this. It comes up with a logical plan for executing it, okay? But an actual physical plan has not been submitted to the cluster yet, so there is no computation happening. The minute you type average length.count, it goes, computes everything, and gives you the result, okay? Till that time, all these operations are stored as DAGs, and it is internally optimizing the computations and things like that. Okay, so count is an action. All these are transformations, okay? So when you're writing, when you're doing your assignment, I want you to visualize exactly what is happening behind the scene, okay? Okay, so very briefly, data frame is a huge step up from RDD. I'm not going to, you're mostly going to be using data frame. So I want to tell you, give you some of the most salient points about data frames. Okay, data frame is again a generalized, sophisticated evolution on RDD. Okay, what it does, the main thing it does is it infers a schema from the data. Okay, so it is a data structure that has a schema behind it. That means you can bring all the power of SQL to analyzing any data stored in a data frame. Okay, so as you know, so you should try this out. When you create a data frame, okay, you can do, let's say you have a data frame called data. Okay, then type in data.print schema. It will give you the schema of the data that it has read in. Okay, and now it's as if you are working with a SQL table. Okay, you can do all kinds of operations on it. Okay, and then I've listed all the other important features of data frames. So you need to be aware of them also. But the main difference between an RDD and a data frame is that data frame infers the schema, and you can apply a lot of SQL-like operations or even SQL functions. Okay. All right. Any questions so far? I think it's been very quick. I'm going to quickly see if there are any questions. If not, we will move on to the machine learning library. Are there any questions? Okay. So, machine learning with Spark. A lot of you have posted, over the past few weeks, about Mahout. I think it was on the discussion for week 6 and 7 when we were discussing HDFS and Mapreduce and their applications. Mahout was a machine learning library, but it was developed for Mapreduce 1. Okay, it is not in use anymore. You should not be using Mahout anymore. There is no support for Mahout. Okay, you know that HDFS itself has evolved, and now you have Hadoop 3.0, which is Yarn, and you have the newer versions of Mapreduce and Spark, okay, running on Hadoop 3.0. So when Spark was developed, Mahout was, kind of deprecated, and something called a Spark Machine Learning Library, or MLlib, was developed, okay. And then later on, even that was replaced with what we now call Spark ML, okay. If you look at your Spark API, either in Python or in Scala, you will see, all the usual stuff, or the usual package structure, spark.mllib, and you will also have spark.ml. You should use spark.ml whenever you can. Not all functions in mllib have been implemented in SparkML, but SparkML has better implementations of the functions that it has. Okay, some functions in SparkML still refer back to the older functions in SparkML-lib. Okay, that's just because people have not gotten to upgrading those functions. But just remember the history at Mahout. Please don't use Mahout. There is SparkML lib. Somebody is asking, let's see, XG boost algorithm is available in ML lib. I think it is available in ML. I don't know if it is available in it was available in ML lib. I have a list of algorithms. Yes, popular gradient boosted tree. Yes. It is definitely available in SparkML. I will talk about it a little bit. Chris is asking if XGBoost algorithm is available in MLlib. It is available in SparkML for sure. Okay. All right. So let me quickly explain the features of ML, SparkML. These are features that are applicable both to MLlib and ML. Of course, you have the data frame. That's how you should try to store most of your data. But I will make some exceptions. There are some algorithms that don't work on data frames. You will have to use RDDs for them. Okay. You try to apply some, fancy clustering function to a data frame, and it doesn't work. But you kind of know that algorithm has been implemented in Spark, then it's probably because it is in the RDD API, not in the data frame API. Okay, there are all those weird things still happening, but it's maturing fast. Okay, And the next important thing is a transformer. The transformer is an algorithm that takes one data frame to another. Okay, that's all. It transforms data into another. Now you know that when you have raw data, you cannot just send it to a model, right? You cannot start training a model with the data. You have to do a lot of cleaning and filling in the missing values and all that stuff. So those operations take place in transformers. Okay, you got to clean the data. You have to prepare the data, do some feature engineering. Okay, all of those are done using transformers. An estimator is what is used to estimate the model parameters. Okay, after you are done transforming your raw data into like a feature set that you want to train a model with, then you say fit, okay, and that will generate the model. Okay, a pipeline is how you fit together lots of different transformers and the estimators. Okay, so I have better visuals. Let me show you the visuals here. Okay, so I have two pipelines, one for training, one for testing. Okay, let's assume we are just doing some kind of a document classification. Okay, so the pipeline for document classification starts with a tokenizer. You just take all the text and you tokenize them, and then you do some hashing term frequency. Okay, that's just going to create a massive matrix with all kinds of frequency counts for all pairs of words and things like that. And then on that data, you're going to do logistic regression. Okay, so your pipeline is simply equal to an array of tokenizer, hashing TF, logistic regression. Okay, that's an array, and that you create a pipeline with that array. Okay, and once you do that, you do pipeline.fit and you feed the data, and it gives you a regression model as the output. Okay, so now for the testing, again you have to do a testing pipeline. Okay, so you pass the data through the same tokenizer hashing TF, and then what you do is apply the data, the transform data to the model. Okay, and it gives you the prediction. So here you say pipeline model transform, and it gives you prediction. Okay, so again here the pipeline has tokenizer, hashing TF, logistic regression. When you do a fit of the pipeline, you're going to get a logistic regression model. Then you set up a pipeline for testing. It's going to be tokenizer, hashing TF, the model itself. And when you transform a given data, it's going to flow through this, and the output will be the prediction. Okay. So, is there any question about this process? It's all very structured and streamlined. Once you know this, you can train and test hundreds of models in a week. Okay, it's all very very simple to do. Okay, and then let's see. Here is the list of algorithms that are available in SparkML. Let me see. Did I list? I have not listed decision trees and with Ada Boost, but it is available. And the list is growing fast, so you should be able to look up the API documentation on Apache website, and you will see all the new algorithms that are available in SparkML. You also have neural networks, and I believe some framework for doing deep learning. Okay, so all of that is now currently available in SparkML. All right. I think I've already taken too much time. So are there any more questions? Any more questions? Okay. Let's go over to Elena and do the walkthrough.
Yeah. All right, so I'm going to go ahead and share. Yes. All right, I'm going to share my screen, and I'm wondering if I should start from the instructions. I'll probably start from sharing the instructions. All right, so I'm going to do the screen share, and I think most of you probably have been able to get through the first page, where the first page you have to download all the files. Remember, you have to download the files from the assignment folder, right? And I would recommend that you go back and download the fresh files. And this is a data set. Now, keep in mind, the data set that is uploaded, it's zipped. You need to unzip the file. And when you unzip the file, it's about slightly over than 1 gigabyte. So just keep in mind the size. And you want to upload the whole file, not the subset, but the whole file. Otherwise, your result might not match the actual result. And there are some questions on a quiz about the results, right? It's just to make sure that you actually did it. Now, you also have to download the quiz questions and the quiz answer sheet. Keep in mind the answers that are going to be graded are the ones that on the answer sheet. It's not going to be something that was circled, and not something that was like a little note written in a Word document that has the questions. It's only going to be graded what's in the answer sheet, and the answers in the answer sheet are final. All right. Most of you probably got through this part. You have to go to the IBM Cloud, and you need to add the Apache Spark service. Remember that your account, student account, cannot have more than 10 services total at the same time, right? So if you ended up adding multiple copies of the same service for the last assignment, you may need to go through and delete what you no longer need to use, right? Because adding Apache Spark, it's a service, right? So most of you are good through here, I think, right? You go to the catalog and you click here, data and analytics category, then you want to pick the Apache Spark. And that's the one that has a little star. That's what you want to do. After that, you're not changing anything, right? You're not changing any setting, you just hit create. So that should be easy, right? Then in the service, important, you need to click on this link in the Apache Spark service, right? You're not going through, you're not going to data science experience directly, right, which was renamed. You want to go through that link, because when you go through that link, some services, something gets set up for you automatically, right? So once you follow that, right, once you follow that, this is what you're gonna get to. This is IBM Watson Cloud. Initially, you're not going to have any project, right? You're not going to have anything. You will have this empty, right? Empty, nothing. But your tools menu should have RStudio, and it should have, well, probably Notebook, but at least you should see RStudio and Stream Designer, at least, right? If you don't see it, then there is a problem, and I'll go over it. So now, assume you have nothing, right? You don't have anything, you're just starting. What you're gonna do is, you're gonna go to the project, view all project, and it's gonna be empty page, of course. You're gonna hit new project, right? Depending on where you click the new project button, you might get a page with several tiles, and it's presenting you with an option to choose. If you get that page, then you're gonna have to select complete, right? And I would have to go back to the one of the discussion questions to show you what I mean. Depending on where you click on new project, you might be prompted to choose the project type. If you're prompted to choose the project type, you want to select complete. So now let's do this. Since I already have a project called Apache Spark tutorial, let me do this. And I'm gonna call it demo, right? You have to use a different name. Then you have to put the description, right? So I'm just gonna do this, and I'm just gonna do, right, I put the description. Next, what I'm going to do is, when you initially start, very important, when you initially start, you're not going to have the object storage. You would have to click on add, right? So I'm going back to this tutorial here, because obviously I don't need to add anything. I don't have the add button anymore. But when you start it, right, well, I should actually step back, because when you start it, this is a screen that you're going to see. Make sure that you have the UMUC, and then you have your organization and your space def. This information should match what you have on IBM Cloud now, right? Former Bluemix. All right. So this is what you'll probably see. Project view project. You're gonna click on the new button, right? This screenshot almost match. There is a different logo, all right? Because the logo was just changed. Anyhow, this is what you will see, right? This is the same. Then, when you start, this is your first project, you'll need to click on add. And when you add this is going to be the cloud object storage, new. And for the plan, this is what you want to choose, light, and click on create. Then you're going to confirm the creation, and you will return to this page. And as it was pointed out to me by one of the students, in some browsers, the refresh button does not work. So it's a browser-specific thing. But it works well, at least for me, in a Firefox browser and in a Google Chrome browser, right? So you're going to click on refresh. Okay? This is important here. And then you're going to see this here, right? So this will happen only when you create the first project. Next project you create, you already see this. Object storage, this, right? So right now, the Spark service is not added automatically to the project. You have to add it. So I'll show you what we need to do. We need to hit create first. When we do that, it will create a project, and it will associate the cloud object storage with the project. Okay? Now what I have to do is I have to go to settings. Check. The first check. You want to see all these tools. Jupyter Notebook, Visual Recognition, Experiment Assistant, Modular, Dashboard, Stream Designer, and Data Preparation. If you don't see these options, then it tells you that something is wrong. If you don't see these options, something is wrong, right? Okay, now, storage. This is my cloud object storage that I just added. You need to write down this number. This is called the bucket number. And because when you start working with your notebook, you have to enter this in a code. So you have an option. You can just copy this, and then you open any editor. Well, it's a notepad on Windows, and it could be another editor on Mac, right? And I paste it in the editor. It might be easier this way, right? So this is your bucket number. I'm scrolling down further. I must add this Spark service that I created on Bluemix. Otherwise, I cannot add my notebooks correctly. I must do this. So I'm not going to click Add Service, right? And I want to select Spark. Very important. I'm not selecting Amazon. I'm not selecting IBM Analytics Engine. I have to select Spark. Right? Now I'm going to be prompted. Which Spark service do I want? Existing. And this is a Spark service that I added to my account in the IBM Cloud. And I'm going to hit select. Right? After you do it, you want to scroll through the project settings and you want to make sure that it shows in here. This is my Spark service, right? It's here. And I still see all of these checkboxes, right? So we should be good. Now, and only now, I'm going to go into my assets page. See this? This means I'm good. And I'm going to click, there are two ways to do it. One way, I can just click on the new notebook. Another way, I can select notebook from tools, right? And then I have to specify the project that I want to put it to. See this new notebook. I click it. I click on new notebook. Now it's going to spin a little bit. Okay, let me see. I think I saw the question. Let me go into the chat. Okay, when I unzip the CSV, the only output was yes. Exactly. There should be a single CSV file. That's right. When you unzip the CSV file, there is a single CSV file. The reason I had to put that file in a Leo as zipped is that the file is huge. I cannot upload 1 gigabyte file to Leo. So I must upload it zipped and instruct you to unzip it, right? Okay? And I'll show you where I initially got this file from. So take a look at this. Yes. No. There are no multiple zip files. There is one. There are several files in the assignment folder. One file is the 2017, right? The CSV file. I'm sorry for confusion. Another file. See that in here? I'm saying there are several files that you'll need to download from the assignment folder, right? And if you look at the assignment folder, the way it's set up is that we labeled each file what it means. So if you go back to the content, right? So let me go ahead and I'm switching to the student view. Alright, so let me go back to the content, and you should see it in a week 8. See this? In a week 8, this is the assignment folder. So what I did was I labeled it. This is the Word document that I'm actually looking at right now. This is a notebook. This is a 2017 file. This is a quiz, and this is a quiz answer sheet. You have to download all of these 5 files, right? So this is the data file. It's huge, and apparently I could not upload 1 gigabyte to the Leo, so I had to zip it. Otherwise, no way, right? Okay, so let's go back to our notebook right now. Oops, this one. Now, what I have to do is I must select from file, right? I select from file, and I have to scroll down, and I'm going to choose my file, right? So, and I have to choose it. Oops, what did I do wrong? Oh, okay. So now I click on choose file, and I'm supposed to choose the Python file, right? Oh, what I did wrong, I was in the wrong folder. Right, so now I have to find the file that I saved, and it's this one. And now what's going to happen is that my Spark service will be pre-populated, and my notebook is going to be named as the same as my file name, but I can edit it. I have an option to edit it. And now I'm going to hit create notebook. That should place the notebook in the edit mode, and it should start the Spark service. Right now, it's waiting to create the notebook. Okay, hopefully, yes, the service should be up and running right now. And right before the session, I checked for the outages, and there are none right now. Okay, so this is a notebook that is going to open, right? And since the interface was just updated, it just given me an option to look at the tutorial. So for you, I would recommend you to read through this. It will help you get familiar. Very important, you want to make sure that you have Python 2. The reason is at the time when we were getting ready for the semester, Python 3 was still in the testing phase. So it was still not ready for us to use. So this notebook, everything was done in a Python 2. But you want to make sure that this is Spark 2.1. So this is the first update that was made for this semester, because Spark 2, the support for the Spark 2 will be stopped shortly, and Spark 1.6 is no longer supported. So Spark has to be 2.1. Just make sure that you see it. Well, not trusted is not a big deal. You can just click here and select trust. That's not an issue. Okay, now what you're gonna do is the next step is to upload the data. Oops, there is more than one. What happened? There is more than one way to upload the data. One way is to click here. You're going to open the slide out panel. Now I'm going to click browse, but before I do it, I must unzip my file. Okay? I must unzip my file, and I think I have it in another folder. Oops. Okay, it's in here, and I have a file. This is a file. So now remember this. This is the actual file size. Right? This is the actual file size. If you don't see the size, then something went wrong during the unzip. So to unzip the file, you could be using a WinZip or the WinRAR, whatever program you have. Now what I'm going to do is I'm going to click open. Something else. We need to be patient here. We stay on this page. We are not leaving this page while the file is uploading. Okay? While this is uploading, I'm going to scroll down, right? This cell, if it's not empty, you want to delete everything. I believe it should be empty, but if it's not, just delete everything. You're going to start from an empty cell. And in here, it's going to say bucket. Over here, right, it's going to say this. It's going to say bucket. Right? This is what you should see. This is a correct notebook. It should say bucket, and it should say bucket in down here as well. See this bucket, and here it's bucket. Right? Bucket and bucket. What you have to do is your task. One of your first tasks would be to replace this guy right here. Right here, you're going to replace with this. Right? This is very important. Wherever it is bucket, right? The first line in the second cell, we're going to replace the word bucket with the bucket number that you wrote down. And this has to be, it must be done before running the code, right? But I'm waiting for this to upload. Once this uploads, we are going to add the credentials part in here. Then we're going to upload the word, we're going to change this word bucket in two places, in here, see this, and down here, right? This is supposed to be your bucket number, right? And a bucket, it's like a container. It's similar to container, but it's in a cloud object storage, right? So it's still uploading. But while it's uploading, let me explain you more. This cell, it's not a runnable cell, that's a Markdown cell. So basically in here you have an explanation, right? It explains what the notebook is. And in here, this is an actual source. This is where I downloaded this file from, right? I'm going to do the open link in a new tab. And then when you follow the instructions in here, it will tell you how to get to the actual file source, right? It will tell you how to download the actual source of the file. But for everyone's convenience, we put a copy of the file in the classroom. It's just done for everybody's convenience, just to make sure that we're working on the same file. Okay, now it's finished, right? So this is what I'm going to do. This cell, this is empty. There is nothing in here. We're starting fresh. What I'm going to do, I put my cursor in here. I keep my cursor in here. And while it's here, I'm clicking on this arrow in here. And I'm going to select this one, very important. Insert Spark Session Data Frame. And I should see the code in here, right? It takes a little bit of time. There we go. Now what I'm going to do, I'm going to keep everything up to here. And I'm going to delete this code. I'm going to delete this. Ladies and gentlemen, take a look at this. What is this? Oh, doesn't this make our job much easier? This is actually the bucket number. So this is another location where it shows up. See this? This matches what I just wrote down. Take a look at this. This is another location where you can get the bucket number. So you're going to do this. You're going to take this bucket number and you're going to copy this, right here. So this line of code, right? The first line of code in the second cell has to have, this is a file name and this is a bucket, right? Your bucket is going to be different from mine, right? And I'm going to scroll down. Here, I have to replace that with my bucket number. I must do that, right? Otherwise, my code is not going to work. Oh, I do this, right? This is what I have to do. And I'm also going to do it here, because here it tells me the code that I would have to run. This is the code that I would have to run if I was going to run the file again, right? If I run my notebook again, I cannot explicitly create a file that already exists, and this command will let me overwrite. Okay. Now let's go back to the top, and we still have to delete this piece right here. This is the first executable cell. I'm going to delete this, okay, for instructions. So this is what you're going to do here, right? This is important. You're going to add the credentials. Then here is the bucket number, and then at the bottom there are 3 places where you put the bucket number, right? Now what I'm going to do, I'm going to start from the very top, and I'm going to run my cells. Of course, when I run the non-executable cell, it's a Markdown cell. I don't expect to see any output here. Well, but to make sure that I don't miss anything, I'm just going to hit run, right? So this is non-executable cell. I'm just advancing to the next one. And I keep on advancing. Advancing. Now, first executable cell, right? Let's see what happens when we run it. Probably at this point in time, we're not going to see the output. But also, we don't want to see the errors, right? So let's go ahead and hit run. Okay, so now take a look at this. This changed to 1, right? It's done. This cell is done. Now we're going to continue. This is non-executable cell, so we just go. This one, we expect to see the first row from the weather file, 2017.csv. This is what I expect, right? I'm going to click run. See this? While you see this little star in here, it means that it's still running. You need to wait. We need to be really patient in here. We have to wait for the star to disappear. And here, see here, it's showing the processes, blah, blah, blah. See this? Number 2. And we see the output. So now we know that this is done, right? Here I see the first 5 rows. So far, perfect, right? I'm going to hit run again, and I'm going to hit run again. Now, this line over here is supposed to return the number of rows in my file. The number of rows that you get needs to match the number of rows that I'm getting right now. If it does not, then there is something wrong with the file. Right? Run. This is the total. This is the number of rows. And it's still running. How do I know that it's still running? Because I see a little star. First, it printed the message, and now we're waiting for it to count the number of rows. Right? So pay attention how long it's taking to run, because it's not instant. This is the number of rows. So please make sure that what you get matches this number. If not, then you would need to go back and recheck your file. Okay? Now, we're going to print the first row. See this? First. First function will print the first row. So I'm going to hit run right now, and I'm going to hit run. It's still running, right? This is my first row. Okay? Now I'm going to add the header. I'm going to add the header because my file does not have the labels, the column labels. And actually, if you click on the source for the file, there is an explanation file that describes all these columns in detail. Right? So now I'm going to hit run, and I'm going to run this cell to add the header. And if I display the first two rows, I should see the headings in the first row and the first data row in the second row. This is what I expect to see, right? And actually, that's what it is. See this? I've got my column headings, and then I've got my first row. Right now, at the moment, the data is not parsed. The data is not parsed at the moment. We are going to parse our data next, so I'm going to hit run, and I'm going to hit run, since right now I'm not doing any executable code. Here, I'm going to parse my data, and I'm specifying that the data in the file is what? It's comma delimited. Every line in the file is comma delimited. So I'm going to parse it, right, into weather parse. Let me run this command. Okay, you don't see the output, right? Because we're not running into the action, right? So now I'm going to see the output, the first. Right? I'm going to run this here. Run. Oh, what happened? There we go. Now it's going to run. Number 7, but it's still... Okay, here it is. So the first row is going to show me the column headings, right? Because I'm only displaying the first row. What is it? It's column headings that we just added, right? Excellent. So now, the indexing starts from 0. This is supposed to give me station, right? This is what I expect to get. So let's go ahead and run it, and let's see. Yes, I got the station, because this here, it tells me, show me the first column in the first row, which is a station, right? Here, I want to see this is first 2. So, before you run it, let's think about it. What am I supposed to get? Just think about it. I'm going to hit run. But for you, let's think about it and then check when it's done. Right? Am I getting what I expect to get? Probably yes, because take a look at this. What does the first do? It gets the first row. 2 in the brackets, remember the indexing starts from 0, so it should be the headings of the third column, which is correct, right? So you want to kind of like check yourself as you're working on this. Now I'm going to explore my data, right? I'm going to hit this, right? I'm interested in the precipitation. There is no output yet from this cell. Now I'm going to continue, and more, and more. And now I'm going to run this thing here. Oops. It's because I did not actually click. Okay, now I clicked it. Now I'm going more and more, and I'm going to see, okay, this is the first row, right? Now I'm going to continue. I'm going to calculate the precipitation by the weather station, right? So I'm done here, and this is my output. Again, I'll have to wait because I see this little star. Right? While I see this little star, it means that Spark is still running the code, and I need to wait. Right? So while you're waiting for it, just for yourself, think about what you should get and what you're getting. Right? So this is a good, this is a time well spent. While you're waiting, think about what you're going to get. Now click run, and then click run, and then click run again, right? There we go. Now we are going to compute the averages per station, right? Run, run. Let's see, is that cell done? Yep, it's done. Now I'm going to hit run again, and I have to wait until it's done. And now I'm gonna continue and continue, right? And now I'm going to continue again, and I'm supposed to see this, right? I'm supposed to see this, and now I'm gonna do the plot. And actually, when you save the file as HTML, for some reason the plots did not get saved. At least it happened last semester. So the solution was to ask some questions about the output. Yeah. So see this? So this is a plot. There are some questions about this plot. The quiz has questions about this plot. Very important. So you want to answer this question. Okay? And this is how you read the plot. This is the precipitation, is the y-axis, right? And this is the station number, it's on the x-axis. And there are questions that you'll need to answer. Now we're proceeding to the Spark SQL section. See this? I run it. Run it. I'm gonna run it again, because here I'm interested in the snow. Which month are the snowiest? Right? I'm gonna hit run again. And let me see. We still have to wait. We have to wait because if you see this asterisk, it means that it's processing, right? Okay. It's done. Now we are going to continue, and this is a Spark SQL, remember? There we go. I'm going to hit run. And we have to wait for this to finish. We're not going to rush. Alright? So, is any one of you tracking how long this tutorial takes to do? Okay. In theory, if it's done right, it should not take more than an hour. In theory. So, the fastest way to do it is to do it slowly, by reading the instructions and following them. Okay? It's very important. Okay, so here it is. This is where we are. Right? Now we're going to run this cell. Run. Okay, so we are done here. We continue. Run and run. See, this is still, when you see this thing here, it's still running. We have to wait. Right? So, until it changes to the number, the kernel is still executing the cell. So you want to make sure that you're not waiting until the last day to do it, because you need to take your time. Okay, now we're going to do this one here. Run. And it looks like it's done, because I see the output, but you still want to check to make sure that you see the number here, right? Let's click run. So this is a plot. This is another plot. There are questions about the plots. So keep in mind there are questions about the plots. Yes. So now I'm going to continue. Run and run. And then again run and again run. Now I have to wait. I have to wait for this to execute. Some commands may take longer than others, right? But in theory, I said 1 hour, okay, but let's say I'll multiply the time by 3. No more than 3 hours for sure, right? Let's wait. Right. There we go. So so far this is fine. Now we're going to do the next one. Save the query into a new table. Run, run, run. Right? We are done up to here. So we continue. Right? Let's see if it's still running. Yes, it's still running. How do we know that it's still running? You want to take a look at this, right? That's one way to know that this is still running. And let it run. I don't want you to be going in and changing anything while it's running. Okay? Just okay, so now it's done. We are going to continue. Right? We need to identify which stations have the same number of snow. Keep going, right? Let's take a look at this. It's still running. We cannot move on. We have to wait here, right? So, while you're waiting for yourself, think about it. What should this return? Right? This is a good time to think about it. What am I getting and why am I getting? What am I getting, right? Okay, so I'm going to scroll down, right? And next step is to save results to object storage. Here you want to do another check. Did I remember to replace the word bucket with the bucket number, right? Remember, this is the part we changed. But to make it easier for you, the instructions say to make the changes first and then run the notebook, right? Instead of going back and forth, we make all the changes first and then we run. Run. Now we're going to run. And let's see, it's still executing. It's still executing. We have to wait. We're not doing anything while the process is still running. This is important, right? We are still waiting. And this is going to write the files into the bucket. And you might be able to access this in Ibm Cloud. Yep. So now this is done, and we're going to continue and continue again, and we are done. So when you're done, very important here, go to File, and you're going to download this HTML, and you go into save this file, right? Depending on the browser, it will probably open here, right? But you want to check where you saved it. And one way to do it, if this is a browser you're using, it's open in a folder. It's going to be in the downloads folder, right? Well, it's for me, but it depends on the setting on your PC. But this is a file. This is one deliverable that you must turn in. Remember, the notebook is 30% of assignment grade. So if you don't submit this HTML file, guess, all right? The second component is a quiz. You need to put the answers on the answer sheet, okay? The answers on the answer sheet are the final answers, okay? Let's say it this way. Now, let's talk about what not to do. And, okay, if you made a mistake somehow, do not delete the object storage. And I have several students in here on this call who will concur with me about the consequences of deleting the object storage, right? So feel free to type it in the chat because there are several students here who deleted the object storage. Deleting object storage will remove everything in here. You want your studio, you want your notebook. It will delete everything. So if you made that mistake, if you deleted the object storage by accident, this is what's going to happen. And I think I saved, there is one screenshot that I saved here. Yes, thank you, Liz. Thank you so much. So Liz, what I did was I borrowed your screenshot, and this is a screenshot. This is what you will see. If this thing, new notebook, is grayed out, right, it means that somehow you may have deleted the object storage. Good news, this weekend, Yelena spent some time with one of you, and we looked through all of the options and compared, and we figured out the solution to this. So we already have the solution to this in place. And what you will have to do is this. You will have to click here, and you will have to go add apps, add other apps, right? And if you see something called Watson Cloud, something like that, you would have to click on try it for free. Not Knowledge Center, but another one. It should say something like Watson Cloud, something along this line. I don't see it because I have it added. You would have to click on try it for free. That will solve the problem. That will solve the problem. It's just how it is. Not sure why at this point, but deleting the object storage will remove everything. Well, it's just like this. That's what it is. And then you won't be able to delete the project either. So, you want to make sure that the object storage is added. And you're going to go to, Jesus, if I click on my project, right? If I click on my project, see this? That's the one that I did. Now, I want to see my available components. When I click here, right? I want to see, when I click on the settings, make sure that you see this, right? These are the tools that you want to see. If you're not seeing an option when you add the new notebook, if you're not seeing the option for Python 2, it means that your Spark service might not be associated with your project. Or it's highly possible that incorrect Spark service is associated with a project. You want to make sure that it's a Spark, not Amazon Spark or anything like that, just the Spark, right? This is very important, right? Because sometimes when you make a mistake, it's very, very, very difficult to fix. Another thing for troubleshooting, if you may have uploaded the wrong notebook, there is no need to delete the whole project. Instead, you could just delete the notebook. You go to Assets, and see this, you scroll down to the Notebook session, and then there should be an option to delete. Oops, what's going on? If you scroll down to the notebooks, you should have an option to delete it. Right? Oops. There we go. Notebook, see this? If I click here, there should be an option for me to delete. See this? Delete. However, I cannot delete my notebook and I cannot delete the project while my kernel is still running. If I see this green circle in the status, it means that my kernel is still running. I cannot delete the project at this point. I would have to stop the kernel first. I mean, I cannot delete the notebook. I have to stop my kernel first, right? See this? I would have to do this and stop the kernel. I'm not going to do it right now, but I'm just saying what needs to be done, right? To go back to my notebook, to return to my notebook, I would need to click on a pencil. This is how to access your notebook from this page. You click on a pencil, it will open back the notebook in edit mode. But currently, my kernel is running, right? Sometimes when I edit my notebook, when I make some changes, I need to restart the kernel. When I make some changes to the code, right? If I ran the code and I made an error and then I updated the code, what you have to do is this. You have to do restart, right? You have to restart. That will restart numbering the executable cells from 1, right? As you run them. And it will start from scratch. It will start running the notebook from scratch. Important, you want to run the notebooks from the top, right? You cannot run cell number 5 until you run the first 4, right? This is very important. So I would recommend the fastest way to do this assignment is to take your time. Take your time to read the instructions and to follow through instructions. And yes, I realize I totally understand what happened because there were big updates to make the system more powerful. They keep on adding excellent functionalities to the application, right? But in order for this to happen, they needed to do the updates. They did updates. So now we have even more capabilities. So let's look at the positive side of it, right? We learned a lot just by going through updates and by troubleshooting, solving issues, right? Yes. So let's see. Let me see. I received the question. So hey Elena, how do you change the notebook kernel from Python 3 to Python 2? Well, first of all, in order for it to be Python 2, you have to add. You need to make sure that you're using the service, right? You need to add you need to associate the Spark service, correct Spark service, with the project, and then you go to kernel, change kernel. See this? I should have this option. If you're doing it right, you want this one, Python 2, Spark 2.1. See this? You want to do Spark 2.1. The reason is these two are already deprecated. 2.1. We are not using Python 3.5 yet because at the time when we were getting ready for this assignment, Python 3.5 was still in the testing stage. So just to make sure that we are working with something that has been tested already, the decision was to stay with 2 for this semester. Okay? So this is how you change the kernel. And if you're doing everything right, you should be able to change it to 2.1, right? So this is very important. That's what you want to do. Python 2 with Spark 2.1. And the reason is because if you try to use 3, the steps should be different, right? So this is going to be our task to do for next semester. Oh, you're the most welcome, Will. So I hope that resolves the issue. I hope. So remember that you have Ask TA Lifeline. Well, I'm using the phrases from the Who Wants to Be Millionaire show. But in this course, you have an Ask TA Lifeline that you may use on your assignments. Right, so now let's take a look at the chat. I have another one. You went a little bit fast about zipping the data. Can you go back to your copy and paste of data in Spark? Oh, you mean to upload the data? Okay, I'm going to show you how I uploaded the data. This is an excellent question. Look what I did. This is, okay. I first must go to my classroom, right? And I'm in a student's view right now. This is what you should see. And I'm going to right click on this link and I'm going to save a copy of this file to my desktop, right? Or on my computer, right? I have to save this file somewhere on my PC, right? And I saved it at the time when I was getting ready, when this assignment was initially prepared and tested, right? So I saved this file. Okay, so it's the file is in a zip format, and the reason it had to be zipped, it had to be uploaded zipped, because the file is too big, and there is no way we could upload the huge file to the. We cannot upload 1 gigabyte files to Leo. Take a look. This is a file that I downloaded, right? And depending on what software you have, you would need to right click and you need to unzip it, right? Extract to, right? I extracted it, and it extracted as a folder. Yes. and see that this is my file, and this is the file size that I should have. Then I'm going to go back to here. Watch. There is more than one way to do it. My notebook is in the edit mode. I'm going to click here, and this will open the slide out panel. I'm in the Files tab, and I have to click on Browse, and then I find where I saved my file, and I select it, right? That's it, and I'm going to click Open, and then I have to wait. In here, I'm going to see the progress bar, and I have to wait until the progress bar reaches to the end. So see this? It's done. After it's done, I'm going to start changing the code, right? So this is one way to do it. There is more than one way. Alternatively, you could upload it in a project page. You could go to the data assets page, right? This is the project assets, and you could add your file from here too, right? Well, there should be a way to. Okay, you could do it here. Yeah, you could upload it here too. But well, I just showed the way I just showed you it works. So I guess follow this way. And I would recommend to work on this assignment, perhaps as soon as you get a chance. The reason is, what if they're doing some patches, right? Because the main update is done, but there is a high possibility that they could be doing some patching in an attempt to fix something. And guess what? There could be some additional changes, right? Nobody knows. Nobody knows. So that's the reason you have two TAs. You have Linus and you have me, right? You have two TAs. So we are here to work with you and to help you with the setup. So you're not alone, and nothing to worry about. Just post questions and you will get help. Yeah. So if it's a new issue, we're going to do the screen share, and we will see, there is such a saying as 2 brains are better than 1, 2 heads are better than 1, right? So I'll work with you, we do the screen share, we'll talk through it and we'll figure it out. One way we could do it is compare the settings in your project with the settings that I have in my project in the working version, right? And we'll figure it out. So don't worry, we'll help you, right? Yes. Okay. Oh, okay. Let me see the chat. Oh, Willem, yes. Thank you, Willem, yes. Yeah, that's very interesting, yes. Well, that's the thing. Sometimes as a TA, we need to know what to do, and in addition to tell you what to do, we need to know what not to do. That's the hardest part about, that's the most interesting part, that sometimes we have to show the students what not to do, and what happens when somebody does it, right? So I want to tell a big thank you to those who reported the issue so far, because it helps the rest of the class. It really helps the rest of the class. So that's the reason we have discussions. So I want you guys to post, right? We are here to learn from each other and help each other, right? So we'll see. And let's see what questions we have. So remember the lifeline, ask TA, right? You have it. So another term I use is a customer service. All right. Sure, Will, you're the most welcome. Guys, do you have any questions, any concerns? I realize everybody is tired, right? So let me see. Linus and Gopati, do you have anything to say? Linus? Gopati?
No, I think you covered it. Sorry, Gopati, go ahead.
Yeah, no, go ahead.
No, this was good.
Finish,
I'm glad you kind of covered all the questions. So that was good. And I saw Gopati's email to everyone. So hope you guys are now going to, download the latest instructions instructions, which is very important, as Elena mentioned also earlier. It's very important. So, if we can go through this step by step and, start afresh, it should be all clean and it should all execute well.
Yep. And I just showed you.
Yeah.
Right. Thank you.
Thanks a lot, Elena. It took a lot of effort to debug all the different issues that were raised. Yeah, I hope everybody now is in a good position to get started with the assignment. Please keep posting comments and questions, and we'll try to get them answered quickly. I hope everybody does well on the assignment. Yeah, and we are always available by email. If you think your questions are going to be interesting to the class, post them on the discussion board. Okay.
So, if we are done, then I'm going to end the recording, and then we wait for it to get from the server. It's going to take a bit of time, because if the recording is about 2 hours long, it's going to take a little bit of time to download. Okay? Oh, so I have a question about the quiz. Well, for the quiz, it's a multiple choice. You put your answers in the answer sheet, right? Or the quiz, you just answer the question. Put the answer on an answer sheet. Put your answers. I hope I answered the question about the quiz. The quiz, you get the answers while reading through the materials and while working on the assignment. Okay, excellent. All right. No more questions or more questions? Oh, okay. I'm gonna stop the recording. Thank you.